Okay, this is TempleOS 5-minute random code walkthrough, episode 34, and I'm your host, Terry Davis. And we are in, looks like the kernel debug. Kernel debug, yeah, okay. So this is set a breakpoint, okay. Address, task, and then if it's live or not. Well, this works, but it's pretty useless. So first of all, the breakpoint is it's a linked list with next, and it's an address. And it's a value. When you insert a breakpoint, you change a byte of code to a CC. I think it's a CC. Anyway, so in the scheduler, when you change tasks, you remove all the breakpoints associated with one task. This is on context save. So when you save tasks, when you save a context, you remove all the breakpoints associated with one task. Replace them with the code that's supposed to be there, and then when you restore the next task that's going to run, you insert all the breakpoints for that task. So the breakpoint is implemented as a 1-byte instruction. CC is the opcode. So if you see a CC, that's a breakpoint. And when you hit a breakpoint, you get a fault. I think it's number 3. Where can we? I'm looking for the names of the F. Okay, so I have a list of all the faults, and breakpoint is 0, 1, 2, 3. Breakpoint is fault number 3. So what we were looking at was where you insert a breakpoint. So it creates a new linked list entry. It saves it. You tell it an address. It accesses the code that you just set the breakpoint on to see what was already there, and then it's a stack. So it does the linked list like a stack. And if the task is the current task and it's live, then go ahead and put the breakpoint in right now. Otherwise, it'll get inserted the next time the task is loaded. Notice we put we pushed the flags, and we turned off interrupts. What that does is it makes the tasks list of breakpoints stable, so that we don't hit this routine twice at the same time. It's a critical section. There can only be one task in here at a time because we have interrupts locked. That's only for core 0. Core 1 could actually interfere with this, but nobody on core 1 is going to set a breakpoint. Only core 0 is allowed to set breakpoints. Let's take a quick look at the now when you hit a breakpoint, it generates interrupt 3. So if we look at the interrupts, it hits the generic. We set up all the interrupts to access the generic fault handler, and the generic fault. All the interrupts come in here, but they've pushed their number. And when we hit this fault handler, we save the context, and then basically we jump into the debugger. It says go to fault 2. So we jump into the debugger. We do a little more stuff. This is kind of a mess, isn't it? But it's necessary. It's ugly. That's what it is. It's really, really ugly. So let's look for the interrupt. There's a breakpoint. So if we hit a breakpoint, we minus the RIP. So we back up a byte. I guess it advances past the breakpoint. So we want to be on top of the breakpoint, so that when we print the RIP in the exception, we get the right address of the RIP, and we print the symbolic. No, we don't. I could swear we print. Yeah, we do print the symbolic of the RIP. Anyway, so there's the interrupt names. That's where we say that's where we get the breakpoint. Here's the interrupt names. These are I do the first 32 are reserved, and then I do some software interrupts. Anyway, so how about that?